Welcome to Brain Vision.
Question number 13 wants us to find the impulse exerted on a stone by a larger object that strikes it. We're told that the mass of this stone is equal to 2 kilograms and that it's moving to the right at a velocity of 5 meters per second. Now there's a graph in our text illustrating the force exerted upon the stone in kilonewtons over time. Time is measured in milliseconds. Initially, the stone has a fairly constant force exerted upon it, but here at 15 milliseconds, it's suddenly struck by the larger object. Its force increases for about 1 millisecond till it goes back down to the original value at 16 milliseconds. At its peak, the force exerted upon it is equal to 2.5 kilonewtons. What we're to do is to find the impulse J exerted upon our stone. The impulse is equivalent to the integral of the sum of the forces upon an object over a certain time interval dt. As we measure from time of the initial impact to the time after. So what we'll have in our case is the lower bound will be 15, the upper bound 16, and we're integrating f dt. What we will have when we integrate that is f times t, and t will range from 15 milliseconds to 16 milliseconds. Now our force, as was made clear by the graph, is equivalent to 2,500 newtons, 2.5 kilonewtons. This means F times T will be equal to 2,500 newtons times 16 times 10 to the minus 3 seconds, value of 16 milliseconds, minus 15 times 10 to the minus 3 seconds. This works out to give us 2,500 newtons times 10 to the minus 3 seconds. That means a value of the impulse acted upon our stone is equivalent to 2.5 newtons times seconds. The next part of this question wants us to determine the stone's velocity, supposing that the force is acting upon the stone from the right side. Now the stone was initially traveling to the right as we started the problem, so we'll call the right the positive direction. Now, impulse, we said, was equal to the sum of the forces from over a certain time interval, but that can also be equated to is a change in momentum. Momentum is designated by the letter P. So the impulse is going to be the change in momentum experienced by the stone over this period of time. Momentum is equal to m times v. So our expression for momentum will have an initial and final momentum. We'll have an initial and final velocity as well. So we want to multiply m by v sub f, the final velocity, by v sub I, the initial velocity of the stone. We already found out what J was in the first part of the problem. It's equal to 2.5 newtons times seconds. And that can be equated to the mass of our stone, 2 kilograms, times the final velocity, which we are trying to find, minus the initial velocity of 5 meters per second. We can just multiply everything through on the right-hand side of this equation to get 2 kilograms times v sub f minus 10 newtons times seconds, value of 2 kilograms times 5 meters per second. We want to try and find out what V final is, so let's add the 10 newtons on the right-hand side of our equation to the 2.5 newtons on the other. That'll give us 12.5 newtons times seconds equal to 2 kilograms times the final velocity. To figure out what V sub f is, in the case when the stone is struck from the right, we simply divide 12.5 newtons times seconds by 2 kilograms. This nets us an answer in meters per second. And if the stone were struck from the right, it would have a final velocity of 6.25 meters per second. And since that value is positive, that means the stone's final velocity will be towards the right. Now, suppose the stone were struck from the left. Well, in that case, we would be dealing with the negative direction. So we'd have the same equation as we did up here, only this time J would be negative 2.5 newtons times seconds, which would still be equated to 2 kilograms times final velocity minus 5 meters per second. Now, our result would look like this. 2 kilograms times V final minus 10 newtons times seconds. And when we add the 10 to the other side of this equation, we'll now get 7.5 newtons times seconds is equal to 2 kilograms times V final. And now V final is going to be equal to 7.5 newtons times seconds divided by 2 kilograms. In the case when the stone is struck from the left, the final velocity will have a value of 3.75 meters per second. And since the final velocity still has a positive value, that means that the stone will still be traveling to the right.